Okay, so here we go. In example 1, letter A, step 1, look for the GCF. There's a GCF. So you get x squared minus 2x minus 15. Sorry, I need to calibrate here. All right, now try to factor that trinomial. You get x plus 5, x minus 3, okay? What? All right, this is not working very well for me. Okay, so in letter B, the GCF is 2y cubed, and I get y squared minus 9. Now what's going to be new for us in this lesson is that the problems are going to continue to factor. What we found in chapter 4 is they usually just did one thing. Now, y squared minus 9 will be y plus 3, y minus 3, okay? All right, letter C. What is the GCF here? 4z squared. So we're going to pull out a 4z squared, and I'll get z squared minus 4z plus 4. So look at your blue factoring sheet, and what does it say to try first with 3 terms? Perfect squared trinomial. Don't forget that, because that can make your life a whole lot easier. So that is a perfect square trinomial. All right, now in example 2, there's no GCF in letter A, but this is a sum of 2 perfect cubes. So here we go. Let's see if we picked it up from our extra practice. This is x plus 4. We square it. You take SOAP, the opposite sign, 4x, n's always positive, 4 squared is 16, okay? All right, try letter B on your own. Now this one's a difference. Okay, I'm getting 3x minus 5 times, whoops, yeah, that's right, 9x squared plus 15x plus 25. You guys get that? Okay, now in letter C, what do you need to remember here? GCF. There is a GCF of 2z squared, so I get 8z cubed minus 125. Let me give you a little trick. If you were trying to think that 4 went in there, if you look at 250, there's a number trick here that if 4 goes into the last 2 digits, then 4 will go into the big number. I've mentioned this before. 4 doesn't go into 50. 4 goes into 48, so 4 can't go into 250 if 4 doesn't go into the last 2 digits. All right, now we have a difference of 2 cubes, so it's 2z minus 5, 4z squared, opposite sign, 10z plus 25. Okay, are we getting the hang of the sum and difference of 2 cubes now? Okay? All right, example 3. When you have 4 terms on your blue factoring paper, what does it say to try when there's 4 terms? Factor by grouping. Okay, so we're going to try our grouping. So I factor out an x squared, and I get x minus 3. Always write down the middle operation sign. The GCF of the last two terms is 16. Now remember, when the middle operation sign is a subtraction, that flips the second sign inside your parenthesis. So this is now x minus 3 times x squared minus 16. Now what you need to get in the habit of doing in chapter 5, factoring, is will it continue to factor? Well, x squared minus 16 is a difference of two perfect squares. Okay? All right, try letter B. I'll give you a head start. Now notice 9t squared minus 1 is a difference of two perfect squares. So that'll give you a 3t plus 1, 3t minus 1. Okay, any questions on that one? Nope, okay. Okay, now let's look at example 4, letter A, 16x to the 4th minus 81. Well, this one is actually a difference of two perfect squares. So this becomes 4, why did I put a T? I do not know. Woo, okay, I'm still back from Thanksgiving break here. Okay. All right, so this is 4x squared, we'll make it plus 9. 4x squared minus 9. Now, I want you to look at your blue factoring sheets. Under two terms, you have three things, right? You have a difference of two perfect squares, a sum of two cubes, and a difference of two cubes. Do you see a sum of two squares on your paper? No, there's no sum of two squares on there, right? There's no a squared plus b squared, right? And that's not an accident, and we talked about this when we factored in chapter 4. There's no way over the set of real numbers that I can factor this. Because if I try 2x plus 3 times 2x plus 3, there's a middle term. If I try in both minuses, there's a middle term. And if I make 1 plus and 1 a minus, it doesn't multiply to a positive 9. So the sum of two squares will not factor over the real numbers. In pre-calculus, we'll look at how we can do it over imaginary numbers, but not this year. But the second factor, 4x squared minus 9, does continue to factor. Okay? All right, letter B. What's the GCF here? 2p squared. So then I'm going to get p to the 6th plus 5p cubed plus 6. And let me refresh your memory if you're like, how did she do that? This is from the exponent property. If I take a to the m times a to the n, it's a to the m plus n. So p squared times p to the 6th really is p to the 8th. Now, this is going to be new for us. Watch how I factor this. P cubed times p cubed is p to the 6th. And notice, if I do an outer inner, I'm going to get a like term of p cubed. And so I'm going to do a plus 3 and a plus 2. Because look, my outer will be 2p cubed and my inner's 3p cubed. That adds up to 5p cubed. And 2 times 3 is 6. Now, that's not a sum of two cubes, so I'm done. Okay, let's look at letter C. I have a GCF of 10, and I get x to the fourth minus 1. Now that's a difference of two perfect squares, x squared plus 1, x squared minus 1. You have got to remember that the sum of two squares will not factor, but my difference of two squares does factor into x plus 1, x minus 1. Okay? So notice the level of difficulty has increased in this chapter. All right, let's look at letter D. What's the GCF here? 3m squared. Do you guys remember the trick to check that 3 goes into 54 and 3 goes into 51? Add the digits. 5 plus 4 is 9, so 3 goes into 54. 5 plus 1 is 6, 3 goes into 6, so 3 goes into 51. Okay? So this would be m to the 10th plus what? 18m to the 5th plus 17. And so this is going to be m to the 5th and an m to the 5th. Now this one wasn't bad at all because 17 and 1 will add up to 18. Okay? Okay, so we are factoring definitely at a higher level than before. Any questions on these four? No? Okay. All right, now we're going to move to solving equations, and I need to refresh your memory from Algebra 1. You have the zero factor property, and the zero factor property says if A times B equals 0, then A is 0 or B is 0. Now this does extend to if I have A times B times C equals 0, then A is 0, B is 0, C is 0. So let's look at example 5, letter A. I'm going to start by factoring it and pull out the 4x. And I get x to the fourth minus 10x squared plus 9. So I'm going to make it an x squared and an x squared. And I'm trying to think of two numbers that multiply to positive 9, but add up to negative 10. Good. A minus 9 and a minus 1. Now, do you notice those are both differences of two squares, so they'll both factor. And then according to the zero factor property, this means 4x is 0, x plus 3 is 0, x minus 3 is 0, x plus 1 is 0, and x minus 1 is 0. That's a lot. Okay? So if I divide by 4, x is still 0. I would subtract 3, add 3, subtract 1, and add 1. So I have 5 solutions here. And it's not an accident that the degree was 5. If you count something called multiplicity, there will always be, whatever the degree is, number of solutions. In pre-calculus, you'll be expected to know multiplicity, but just to plant the seeds this year, if somehow I had x plus 3, you'd only write x equals negative 3 once, but it would have multiplicity 2. So if you counted how many times it occurred, it's still going to add up to 5 times, but I may only write like 4 answers then, okay? So multiplicity isn't a difficult concept. All right, try letter B for me. Get everything on one side equal to 0, and then factor it. guys, just remembering what happened in chapter 4, don't lose your equation. Some of you would drop your equals 0 and be factoring and then magically put the equation back in. Please be careful that you are having your equals 0. Okay, now x squared minus 5 is not a difference of 2 squares, okay? So it won't factor. But then I'm going to set 3x equals 0, x squared minus 5 equals 0, x plus 1 equals 0, and x minus 1 equals 0. Now, there is a method to my madness. The worksheet you had due today, do you remember the second page, was all solving quadratics by the square root method. Now you're going to see why I asked you to do that. Right here, if I add 5, you have to do the plus or minus square root 5, okay? Do you see that? So this is the first time you've seen this with an x squared with our factoring, but it ties into what you learned in chapter 4, okay? It really does go together. Then this is x is negative 1 and x is positive 1. So the degree is 5. I have 1, 2, 3, 4, 5 solutions, okay? All right, go ahead and try letter C. Remember to line them up in a descending order before you try to factor it. Okay, look for your GCF and try and go the whole way through. So don't forget the plus or minus square root, okay? So did you get x is 0, x is negative 2, x is 2, and x is plus or minus square root 3? We getting the hang of it? Yay. Okay. All right, now in letter D, we're going to ramp up the level of difficulty one more notch. Go one more time. So if I add the 6x to the 4th, remember you want to have your leading term be positive, okay? So instead of bringing the x cubed and x squared to the right side, we want to move it over to the left. All right, so it looks like we have a 3x squared. And those of you that like the AC method, if you're looking for two numbers that multiply to a positive 10, but add up to a negative 9. Now I want to pause here a moment, and this is going to come back to very, very basic number sense, okay? Back to maybe 3rd grade. If I have, well, not really, maybe 5th grade. If I have two numbers that multiply to a positive, they have to be the same sign, right? To get a positive number, they're either both pluses or both minuses. So, but if I want a negative sum, they would have to be negatives, right? Well, that doesn't work. There's no other options. This doesn't factor. Well, just because it doesn't factor doesn't mean there's no solution. I'm going to set 3x squared equal to 0 or 2x squared minus 9x plus 5 equal to 0. So I'm getting x is 0. I don't need to write it twice. That would actually have multiplicity too. But then what other tool do we have in our tool belts? I think I've got it right here. I have quadratic formula that will help me solve a quadratic equation that doesn't factor. So here we go. X equals negative b plus or minus square root b squared minus 4ac all over 2a. And you don't want to use your program unless it says to give a decimal, okay? So I'm getting 9 plus or minus square root 41 over 4.